Hi, I'm Fumifa Goimbo, and in this video, I'll walk you through my voice over IP or VoIP setup. This is a submission for my CISA 3360 skills exam. Before we dive into the lab, let's quickly cover what VoIP is. VoIP just means sending voice calls over an IP network instead of traditional phone lines. It started in the mid-90s when companies began using the internet for voice calls. To make it work, you need a few key components. IP phones, a call processing system to handle signaling and routing, switches that support voice VLANs, and a router with QoS to prevent call delays. Most setups also use PoE switches for power, DHCP for IP addresses, and a TFTP server so phones can pull their configurations. Put it all together and you have a setup that delivers clear, reliable calls in a network. For this project, I used Cisco Call Manager Express or CME. Think of CME as a simple router-based phone system. It handles call routing, extensions, and dial plans without needing a full Cisco unified communications setup. It's perfect for small offices, labs, or classrooms, but for large enterprise or multi-site environments, you'd want the full Cisco Unified Communications Manager. Here's my setup. I installed two Cisco IP Communicator soft phones on two Windows Server VMs, both on the 192.168.5.0/24 network. After assigning IP addresses, I verified connectivity by pinging between devices. Next, I set up a Linux Mint machine and installed Dynamips and Dynagen to emulate two Cisco 7200 routers. Dynagen is a text-based front-end for Dynamips that manages the virtual network topology. Each router runs CME to support the IP phones. I used a script to bring up the routers. Here's what it does. First, it kills any old Dynamips processes so nothing conflicts. Then, it creates two tap interfaces, tap 1 and tap 2, and attaches them to my Linux bridge. This gives the router virtual network cards so they can talk to my VMs. The script brings both interfaces up, and finally, it launches two Dynamips router instances, each mapped to a tap interface and assigned its own console port 2521 and 2522. Each phone needs a TFTP server to download its config. Phone 1 points to router 1, phone 2 to router 2. On each CME router, I enabled the telephony service to act like a small PBX. I created ephones for the phones and assigned directory numbers with ephone DN commands. Each ephone is linked to a DN using the button command. The requirement for this setup was button 2:1. This means that I am assigning directory number 1 to physical button 2 on the phone. Finally, to allow calls between phones on different CME routers, I configured dial pairs. Dial pairs define what numbers to match, where to send a call, which codec to use. I created VoIP dial pairs on both routers using the remote phone's DN, the remote router's IP, and the G711 codec. After this, the phones could call each other seamlessly. In conclusion, this project demonstrates how organizations deploy internal VoIP systems. It covers IP addressing, TFTP provisioning, phone registration, directory numbers, call signaling, and inter-router call routing, all essential building blocks of modern telephony. Thank you for watching.